So my name is Mr. Ayers. I was a calculus teacher for 3 years. I loved calculus, so I'm really happy to join you guys for some time today. I'm going to be primarily working and writing up on the board. My handwriting is atrocious, so if there's anything that you can't understand, please ask me to rewrite it and I will gladly do so. Like, don't feel afraid. Just don't call it ugly, that really hurts my feelings. And then I'm going to be using the DocCam to model some calculator skills when we need them. Okay? I don't want to assume any calculator skills that we may have. So again, if you feel like I'm going too quickly over the calculator skills, please just let me know. I'm trying to adjust the lights on here. Hey, Daniela.
Yeah.
And it might be a little funky at first, but we're just going to use the DocCam primarily for the calculator. Everything else I'm going to write up on the board. So right now I'm going to go ahead and cover it up. Let's start. Let's actually introduce ourselves. Let's go around, just say our names and our campus that we're from. So let's just do this real quickly around the classroom. So.
I'm Mariana and I'm from Southeast.
I'm Eileen, I'm from Southeast. I'm Angela, I'm from Southeast.
I'm Daphne, I'm from Southeast. I'm Tariana, I'm from Southeast.
I'm Jared, I'm from Brazil. I'm Irving, I'm from Brazil. Tony, I'm from Southeast.
I'm Junior, I'm from Southeast. I'm Miguel, I'm from Southeast.
I'm Daniela from Brazil.
Natalie from Brazil.
Miriam from Brazil. Marilyn from Southwest. Julissa from Southwest.
I'm from Brazil.
Jeanette from Brazil.
My name is Jose, I'm from West.
My name is Jasmine from West.
I'm Anna, I'm also from West.
I'm Karina from Southwest.
Perfect, awesome. And so I used to be the calculus teacher here at Braze Oaks, and now I'm at Northbrook High School, where I work with our science and math teachers. We don't quite have calculus yet, so I don't get to talk about it every day, so if I sound a little bit rusty, it's just because I'm getting back used to it, but I'm really excited to work with you all today. So, let's go ahead and let's take the first 30 seconds of today just reading this problem. So everyone should have a handout right now. If you don't, they're up here. But go ahead and just read that initial problem, okay? All right, about 20 more seconds reading this problem. Emmanuel. About 10 more seconds reading. All right. So I think there's at least 3 vital pieces of information that I need before I get started. Can I get 3 hands up to tell me any of the 3 things that we might think are really important to this problem? Anything that we took from reading it? Yes?
R of T and DT.
R of T and DT. So what does R of T do?
What does it do?
Yeah, tell me about it.
Measures cubic feet per hour.
Cubic feet per hour. Is this water entering or leaving the pipe?
Entering.
Entering. So R of T is the amount of water entering the pipe. So I'm going to go ahead and draw a picture. I would draw this at the top of the notes. I think that this is a really good approach to this problem first because it helps us figure out exactly why we do certain things later on. So R of T is the amount of water entering the pipe. D of T is the amount of water leaving the pipe, right? Cool. So let's go ahead and let's draw our picture as best we can. This is my fancy looking pipe. And one thing that he said, I forgot his name already, is that the units are cubic feet per hour. Cool. What's another really important part of this problem that maybe from reading it I should take away? Oh, you already tried. Let's get something else. Thank you, Will. Thank you. Emmanuel.
The initial water is 30.
So the initial water is 30, meaning that there's already water in the pipe when I start looking at this. So if you have a blue marker, this is a really great use of it. There's water already in the pipe. How much water, Emmanuel, is in the pipe?
30 cubic feet of water.
Cool. So my initial amount is 30 cubic feet. And there's one final thing I think it's important to mention. One final thing before we really dive into this problem to make sure we've internalized it correctly. Yes?
On the interval 0 to 8?
Cool. On the interval 0 to 8, meaning I really only care about what's happening in this problem for t values between 0 and 8. So that I really want to limit my viewpoint here, okay? So this is a calculator active question. So the first thing that I think we should do before we jump in is let's go ahead and enter these functions into our, what's the word, calculator? Let's call f1 of x r of t and f2 of x d of t. So if you have a calculator, go ahead and do that. I'm going to write those there. I'm going to uncover the projector and type it in case we need to model it and see it. And since we have a trig function, let's just go ahead and preemptively check that we are in radians. Bringing it back together in 45 seconds.
I messed up. Thank you. I think it's too early, so wait. Oh, right here. Is that right?
Alright, so we should have both of our functions in our calculator. This might be our initial screen. Some of us might be jumping ahead and fixing our window based on our close interval. That's great. We'll talk about that when we need to. I always think, wait until we see if we have to do it for the problem. So can I get somebody who takes AP English Language with Mr. Leon at West to read question A? I know some of you do.
How many cubic feet of rainwater flow into the pipe during the 8 hours from interval 0 to t?
Cool. So how much water is flowing into the pipe on this time interval? So since it's just how much is flowing in, I really only want to look at my function r of t. So I'm looking for a total amount. And since it's just the amount of water entering, I'm just going to use r of t. But since I'm trying to figure out exactly how much entered over a certain interval, that's where I'm going to use an integral from 0 to 8 d of t. Okay? The integral from 0 to 8 r of t times d of t We've just gotten our first point on this problem because we've written the correct integral. D of t matches our function, our limits are correct, and I'm going to use my calculator to see what this equals. So I'm going to give us all a second to sort of set this up on our calculator. I'm going to take back off the screen and go ahead and enter it with you all, okay? Remember, r of t is f1 of x. Bless you.
Thank you. I appreciate it.
If you need help finding the integral button, you can hit this button next to 9. And the integral, I believe, is right here. 3rd row, 2nd column. Okay?
You can also do shift plus.
Shift plus is the trick, I believe. So I'll do that next time. Shift plus. And I called it f1 of x. Uh-oh. What do you think happened? Did everyone get the same number?
No.
No. What do you think happened?
It's in degrees.
It's in degrees. Even though I adjusted it on my graph, this calculator did the annoying thing where it didn't adjust it on my calculator. So I'm going to edit it right now. We should be getting 76.570. Give me some snaps if you got that. There we go. So 76.570. Let's bring it back together. So over the first 8 hours, 76.570 what entered the tank or the pipe? Cubic feet. Awesome. Cool. And that's it. 2 points. 2 points on our first exam. Usually this is the first calculator active for response question. Writing an integral and evaluating it. Okay? All right. Can I get somebody from Southeast to read question B?
Is the amount of water in the pipe increasing or decreasing at time equals 3 hours? Give a reason for your answer.
Okay. So I want to see, is the amount of water increasing or decreasing? At a specific time. Now, usually when I try to see if something's increasing or decreasing, I look at its derivative, right? And if its derivative is positive, it's increasing. If it's negative, it's decreasing. Because this is a rate function, what I actually want to do is I want to see which one's larger. Is r of 3 going to be greater than d of 3? Why would that represent increasing in this problem? Can somebody raise their hand? Why would that represent the amount of water increasing? Person in the Carlton shirt, right? Carlton? Yeah.
Water, there's more water going in than going out.
There's more water entering this pipe than there is leaving the pipe. Okay? So that would mean that more water is coming in than less is going out. So it would have to be increasing. Okay? What would I say if it was decreasing? What would be the situation if it was decreasing? Emmanuel?
R3 is less than Q3.
R of 3 is less than D of 3. So let's go ahead and let's find those two values here. Go ahead and plug into your calculators. I'm going to give you guys 37 seconds. Find what R of 3 is. Find what D of 3 is for me. Some of us are using a table. Some of us are plugging this into our function, saying f1 of 3, f2 of 3. Some of us are tracing on the graph. We have about 16 more seconds. 3?
5.0386.
Cool. And for D of 3? 5.4? Cool. That's what I got too. You're good? Cool. Perfect. All right. So, my friend back there said that he got the same thing. So for R of 3, it was 5.86. I actually got 3.7. I always like using more decimals. 5.40000. And all of these are rate functions, still values of rates. So I'm just going to write my units, even though I don't think I'll need them. So what's my situation? Is the amount of water increasing or decreasing? Could you explain why it's decreasing again? More water is going out. So all we need to write, all the AP rubric asked of us on this question was that we write since R of 3 is less than D of 3, the amount of water is decreasing at T equals 3 hours. Okay, you could have written D of 3 is greater than R of 3. All of this right here wasn't necessary. The AP rubric did not ask that you have to write these two values. I'm just somebody who likes to see it written just so I can have it in case I need to check it later. Okay? We did need to compare the two. Okay? Rather than finding these, what's another way we could do this, maybe using a graph?
You find the derivative and see if, like, for example, if R of 3 is like, if the prime is increasing, then that means R 3 is increasing.
So I think you're thinking the right thing. We'd try to see like which one would be increasing more, right? Like based on finding those derivatives. But there's actually a much easier way using the two graphs. So let me see if I could make a graph of it. What is it? Grid. Emmanuel, what were you gonna say?
Would it be possible if you took two separate integrals, one of R3 and then of the R and then another integral of D2?
I can tell that we have some of the smartest minds in this room in the district, and sometimes we miss the simple things. We're missing one very simple thing, okay? Not to make fun of you, Emmanuel, it's okay. Jeanette?
You can't just see which equation is on top.
All you could do is look at the graph and see which equation is above the other at 3. If you looked and noticed that one graph was above the other, this statement is still true, okay? So, really thinking, like sometimes in calculus we feel like we have all these tools and we're not quite sure that it's just sometimes the simple things of comparing the graph, okay? Again, thank you guys for sharing some ideas. This was a really trick question. I was trying to lead you down a rabbit hole. Thank you guys so much for participating, okay? Let's read question C now. I'm going to give you guys a few seconds to silently read question C, because this is where the bulk of our work comes in. To be honest, I looking at the graph, what we're thinking. No, because that doesn't tell us exactly what's happened at a certain time. That tells us what happens over a certain time. But maybe at 3 it's like changed. All right, I'm going to erase my work up here for A and B, because C is the meaty problem here. All right, so what am I looking for at C? Can somebody point out what's a key word that I should be aware of for C? Minimum. So I'm looking for a minimum. And I'm going to turn on the lights here because there's a lot of writing on for this one, so I just want to make sure that we can see everything. All right, so I'm looking for a minimum. What's something that should stick out to me about this problem? Bless you. What's something that should stick out to me when I see minimum? Looking again at this question, what's something that it provides that I need to be aware of? Yes.
That the derivative must be going to decreasing to increasing?
Right, so when we see minimum, we know that our derivative is usually going from decreasing to increasing. There's a lot of ways I can think about this. Decreasing and increasing is one of them. What's another thing I should be aware of for this? We probably did this back in November, where when I have a closed value, what must I do when I have a closed interval? You guys remember the absolute extrema theorem? Maybe it's a little fuzzy in our mind. So, if I have a closed interval, what this tells me is that I must test the endpoints. Okay? So what I'm going to do is on my graph, on my paper, I'm going to make a table. And on the table, I want to have important values of t. And once I find that value that was shared out about where f prime would go from decreasing to increasing, where minimums occur, I still need to check my endpoints. Okay? I'll still need to check my endpoints. Now, this next part of knowing exactly how to find other t values depends on this like drawing of the graph and us interpreting the situation. Okay? So let's say that the amount of water goes up to a maximum and then stops. And then it decreases to a minimum and then stops. The values that it stops at, a max and a min, would occur when there's no water entering or leaving the tank, right? They're leaving at the same rate, so there's no more being added or no more being taken out. So max and mins here occur where r of t equals d of t. Because at those points, the amount of water in the tank would not be changing, okay? So I also want to find where r of t is equal to d of t. Now I could set these equal to each other and try to solve very ambitiously with algebra. What should I probably do instead?
Find the intersection.
I should find the intersection point. So let's go ahead and let's adjust our graph so that we're looking from 0 to 8 and find those intersection points just between these two values. Alright, so right now we should be editing with our calculators, editing our window.
Yeah.
I know that for my x min and my x max, I'm only looking from 0 to 8. And I don't have a really good idea of what to do for the y, so I'm just going to test out 50, see if I can see anything. Oh, cool. How many intersection points will I need to find? 2. Just this one here that I see right there. So I'm going to go ahead and find that. So R of t and d of t are equal to each other at this value. This is where, if I look at my two graphs, I have my water leaving the tank or the pipe and water entering the pipe. But at this value, since they're equal, that means the same amount is coming in, the same amount is leaving, so it's not changing. So it's either going to be a maximum or a minimum value. Now, one thing your calculus teachers may have shown you is that people sometimes like to call these points A. Raise your hand if you've seen this, like your calculus teacher call the intersection point A. Okay. I am a very lazy student of math sometimes, and I always forget to do this, but since some of us have seen it, I want to point this out as something you can do. Okay. So you can choose to write 3.27166, or you could just write A instead. As long as you've defined it earlier on as what A is, you can use it later. You just can't use anything that's already been used before. Okay? All right, so we've done a lot of work to find this one value. What do we think we're going to do here for this expressions here? What am I still looking for? Oh. What am I looking for again? The minimum. I want to see which of these three values is the minimum amount of water. So, how much water was there initially in the tank? 30. Done. That part's easy. For these next ones, this is where my integrals of values come in. So I start with 30, and I'm going to add how much water has entered the tank, and subtract how much water has left the tank. What's something I can do for this next one? Purposely, I split this up into two integrals. Does it have to be split up? No. I could have combined this into one integral here and done R of t minus d of t times dt. So I'm going to give you guys about 30 seconds, plug these into our calculators, and see what we get as our value, okay? You can write this as two separate intervals, or sorry, not intervals, integrals, or one integral. It is entirely your choice. Do something useful, Urban. Cool, make sure you're using two decimal points, okay? Especially for up here on the upper limit. The second we start rounding too early, it means this answer is going to be rounded the most super far off. So that's why for this one, use as many decimals as you can, and then round it to the very end. Okay. So why don't you replug it that one? You need a calculator?
What is it? Just the one with.
I know, I was okay. Why don't you guys plug it? You guys need tricks.
No, I don't want to.
Oh, you can give me $20. You just can't leave.
¿Ya te vas a ir? ¿Ya te vas a ir?
No, Mr. All right, so we should have gotten that at our point A, our intersection point, 27.965 cubic feet and 48.544 cubic feet. Okay? Now, where does my minimum occur? At my intersection point, at 3.27166. Notice that the question says justify your answer. This table in itself is the justification. You stated that you wanted to find the intersection point where these are equal. That's a point. You knew how to find the values you needed to check. This table has all the values that you need to test, the two endpoints and any intersection points. There's a problem later on in this packet where there's like 3 intersection points. It's a lot of work. But once you set up your table, you're doing the same integrals for each time. Okay? All right. So right here, you're done with this question. We don't have to write a statement interpreting it. We could say that the minimum value is at 3.27166. So let's just do that at the top. At what time is the amount of water in the pipe at a minimum? We could say at T, 3.27166 hours. And I don't know how to spell hours, but that would be the conclusive statement. Okay. This is the culmination of all the work we've done. Now, this is very common of the College Board to do this. We've just done a lot of great work, and then they've put this longer text question at the very end. Okay? Sometimes they like to hide easy points at the very end of the question just to see if you'll persist through it. So I always suggest read through it. So I'm going to give you guys a second right here to just read question D for me. Okay? My handwriting's improved. Yeah. Thanks. Thank you. What day is the 18th? May 9th? Guys, I need help with this joke I'm about to do, okay? I need help. I need to know the day. What day is the AP exam? Yeah, weird. No sense of it. Alright, I'm gonna figure it out. Alright, so whatever day the AP exam is, what are the 4 favorite words of a calculus student? But do not solve. If you see but do not solve, it literally just wants you to write something, okay? So here, it wants us to know when will the amount of water in this tank equal 50. So question D, I'm going to be a little bit scattered because I want to leave this up here. I just want to know when is the amount equal to 50. What's the time W where that's equal? Well, I know that I started off with 30, and that from 0 to time W, water entered the pipe, and water left the pipe, and there's some value here for W that will let this equal 50. And I really got cut close here with this 0 right there, so I'm just going to erase that. But do not solve. So many times the College Board will read papers where they see people like subtracting 30 and getting 20 on one side and then trying to combine it and then trying to find antiderivatives. Look out for that but do not solve so that we can get some good chances just earning some points, okay? All right. We are going to jump ahead to page 5. There's a few multiple choice problems I want to make sure we get to do, but there's a free response problem here at the very back that is very much aligned to this one. So at your tables, using the power of not just people at your campus, but at people at other campuses, please talk together and let's work on practice free response number 2. It's the one about a water tank at Camp Newton, okay? Very similar to this question. I'm going to be bouncing around helping out. Make sure we have some good conversations with each other, okay?
WT has to be greater than
Yeah. Esto, ¿verdad? ¿Es el plus? But so you just squaring the x and you squaring
Oh, like how to put that. Yeah. So real quickly, a good thing to point out is if you have sines squared of something
There's two signs, actually, I don't know.
for both of them, what you do in the calculator is you can't put the signs or the square right on the sign. You have to put it outside the parentheses. Okay? That's because the sign is being squared, and so make sure it's here. Okay? You can't, the calculator can't read it if it's right there. Sadly. Okay. You two work. Not much has changed from your junior year. Keep working. How do you work? So it wouldn't be. So you can say no, it is not increasing because, or let's, we can't say it. So what should we say instead of it?
The amount of water.
Amount of water.
Oh, I subtracted.
Yeah, I know. I got it. Oh, yeah, I have the other one too. Still don't want to check though. Yeah. So wait, the amount of everything was 1.
Yeah. Hey, you're right.
From 0 to 18.
You got it right. Oh, I'm sorry.
So t equals 5. So it's that right? WT subtract? Yeah, because you have to take out the ones that are.
Oh, genius. He's right over here.
So that's a perfect thing to say is our.
Yeah. I tried to put all the smartest kids in here first.
Yeah.
So it's downhill from here.
Yeah.
Careful, I have really serious my hair falling off.
Yeah, I would think.
But it already has.
Let's do that.
Yeah.
What'd y'all get?
Okay.
Yeah.
14.
1410? Why? What'd you get?
Yeah, did you guys 1200? What did you get? Go to the go.
I didn't put it in.
Another chair. You dropped $2.
Sit right there, Tony, engineer. Plug it in, let that go, right?
What did you get?
1410?
I got 1309.
What?
I put it in different for you though. Definitely not that
The work looks the same, but
This? Was that upright or is it like that?
Wasn't it the same thing? Yeah, it's the same thing. It's the same thing. I just put it on.
you got a different answer.
What'd you get?
I got 13. Oh, I'm sorry.
I put mine in like a.
So, yeah.
Let me try to plug it in like that.
There we go.
Are you over here too?
So,
Maybe it's the ground. They do it.
oh yeah, grab the safety. We got 14 from 10.
What did you get?
That's what I got too. I plugged it in the way you wrote it and I got
Just because we used different ways.
It changed the graph.
Tony, you plugged it in.
So,
What do you mean?
y'all get it was 1309?
Let me see your graph.
So they got 1309.
No, yeah, right.
She got 1309.
Yeah, I think
That's 30. That's actually
Yeah, that's right.
No, but no, and I think our.
What's that? Their grandma's mom.
Why are you lagging?
At what time do the amount of water you take? Hey, if you have to do this for this. For this? Can you find the intersection over here? Me?
Raise your hand if you found the intersection points. I should know.
Week 2 and then
Yeah, there's too many. From 0 to 18.
Oh, wait. Really? It is like, what are we doing?
Absolutely Extrema theorem. What that basically says is that we're looking for a maximum, like a maximum closed interval. Absolute number of maximum exists.
And the next one.
You will also have to set the endpoint.
So if you're looking for mathematics in an open interval,
What's the number?
but if it's closed, because that means
Here you go, Connie. Just plug it in and get it. Take it away.
so there is no absolute.
If it's closed, we'll check endpoint.
Yeah, so if like, if this just is between 0 and 18.
Can I do your one here, like all nice? Yeah?
Literally,
Screaming last time. Screaming. Wow.
Okay, 13. It doesn't have to be 2, 3, 6.
The first time.
I know, I can tell you.
you actually do this 1 point.
Maybe tell I don't do it to myself. Because I can't do it.
2.49. I haven't done my others in a year.
I haven't done them in like 2 months.
I let him grow out. I did it myself.
I let him grow up to that one
Really?
time.
Oh, really?
I can't do one of those. I can't do that. I just get it myself.
There you go, Tony.
Mommy, you know
Yeah, really?
Really?
Yeah,
Yes, okay, yes.
Yeah. So I took them out and I was like, what's the intersection? What's the intersection?
There's 2.45 and
6.45 and what? 4.97? It's a this, right? Basically.
You want to start looking at the first question?
Are you sure?
Who's the other? Let's go.
I mean, this one for all of these,
Yeah, you do.
the numbers.
What numbers did you get?
6.45 and 12.97.
What is it? Is that the intersection?
This is the total, right? All amount. So you would just add it. Most of the time, you get full credit for this.
Wait, tell me, I'm gonna look at this real
So which one would I have to apply? total amount of water.
So K would only be for one interval. It would be on the removal. Like, would you go all the way to 18 and then find how much? So you could just make it from 0 to K. Because so we have the initial amount. We know that we're only adding the first 18 minutes or hours. So this is like how much is it added, right? Now, K is some value. K is necessary. We're sort of like it's not fine. So we could technically say 0 to K of R of T. Okay? Mainly because if you were to try to do two integrals, minus 0 to 18 minus 18 to K, properties of integrals mean you could just combine those. If you had two integrals, 0 to 18 of R minus 18 to K of R, you could just combine these two new properties of integrals.
But I can't continue right now.
No, for
Say that. That would be something different. So if it's talking about proportions, like direct proportional or inverse proportions, that would be probably most likely different. Where you would set up your equation. So if it says,
So you go to 0 to 18, right?
like y is directly proportional, we know it's y equals k times x. If it's inverse, y equals k over x. And k is the constant proportionality. That might be what you're thinking about. Yeah. But that usually comes up in differential equations, not in rate questions like this. Okay?
Or maybe it's minus because we
Alright. Alright, we're going to do a real quick review of this question, okay? There's a lot of multiple choice questions in here that are connected to this topic, which would be great for you guys to work over. Sorry that we didn't get to it. I'm going to do a quick review of this question. I got a lot of answers from you guys for your hard work, and so if there's any questions, please let me know. All right, so I made a mistake on A. What's probably my mistake? I made a mistake on A. What do you guys think I did? I was in degrees mode, okay? Now, notice I would still get my second point here. Even though, again, this question doesn't want us to know what the values are, it wants us to know what we're looking for. So if I wrote this, they're like, well, this kid's obviously thinking the wrong thing, but my interpretation of my answers is correct, so we get that follow-through point, okay? Always make sure if it asks us to justify or write, we write our statement here, okay? This is what I got for B. A tricky thing here, what was the tricky thing here, Marilyn?
That it asked for the nearest number.
It asked for the nearest whole number, okay? We probably haven't done rounding in a while, and it asked us to round. And again, we try to say don't round, don't round, don't round. Use 3 decimals. Here it's asking us to round, but we want to get our point from our correct integral and the correct value. Question C, my absolute minimum occurs at this point here. This is my intersection point. I've got my justification. I would just need to say that the minimum amount of water occurs at t equals 6.495, okay? Now, we're about to leave and go to our next session, so it's been fun. But I want to make sure we talk about this last one, okay? You can ignore this right here.
You're right.
And it's very messy handwriting because I was writing upside down. But notice this question says that K is sometime after, that doesn't say after 18, but it's sometime where the tank becomes empty. We're assuming that T is going beyond 18. Notice here, I saw a lot of people trying to do some interesting stuff with where K comes up, but we could just say subtract 0 to K, the integral from 0 to K of R of T, okay? We don't need to have two integrals here because properties of integrals say that I can combine these two and that K, would extend beyond that value, okay? So that the total amount of water that leaves the tank from 0 to K must take away this initial amount and how much has entered from 0 to 18. Okay? Guys, this has been a lot of fun. Hopefully we got some good practice and some good skills in. It was great getting to see you. We are all going to the next session together. So go ahead, you can copy this down. If you need to use the restrooms, they're towards the back. Okay?